Hi guys, let us look at this last example on transforming a complex number from standard form to a trig form or a polar form. Guys, here I have a purely imaginary number, negative 3i, and we want to convert it or rewrite this in the polar form. We already know that to write it in a polar form, we need few things. One, we need the absolute value or the value for r, and we also need the angle theta. So guys, first of all, what we should do is we should try to rewrite this with a real part and an imaginary part. That's what we have been doing for all of these examples when we have to convert from a standard form to a polar form. So I'm going to rewrite this as 0 minus 3i because that's not going to change this complex number, but this way we're able to see the real part. And then obviously we also have the imaginary part. The real part a equals to 0, the imaginary part b equals to negative 3. We can kind of consider this or look at this as a coordinate pair 0 comma negative 3. Let's go ahead and plot it in a complex plane. Guys, these are complex numbers. We're not going to just plot them on a real plane. We are going to plot them in a complex plane, and complex plane is somewhat similar to a real plane, except for we call the horizontal axis as a real axis and the vertical axis is thought of as an imaginary axis. So 0 and negative 3, obviously 0 is right here and we have to go down 3 units. Let us say this is my point, negative 3, and then this would be the complex number, which is represented by z equals to negative 3i, or you can also think of that 0 and negative 3 on the complex plane. Now this is my point, and let us join these two. Well, it's already on the imaginary vertical axis. Now first of all guys, I need to figure out my r. We already know r is the distance from the origin. How far is this point from the origin? Well, it is below the horizontal axis. This point is negative 3 down, but as far as the distance goes, you have to take the absolute value or magnitude of that number. So we already know, without even trying to set up any equations or any formulas, we already know it is 3 units away from the origin. So r obviously would be just equal to 3 units or 3. And then we also need to figure out the angle theta. Guys, keep in mind, we always measure the angle with this as a reference side, and we like to measure angles in the counterclockwise direction. That means we are trying to figure out this angle right here, right? This is my theta. Right, to find that theta, again, we don't really need to use any trig formula, sine or cosine or anything. It is pretty simple. We already know that from here to here it's 90 degrees, then 180, and then when you go up to here it's 270 degrees. So that means theta is just simply 270 degrees, or if you want to write, or if you want to think in terms of the radians, it is going to be 3 pi over 2 radians. And then if we have to write the polar form, first of all, I'm going to write the general way of writing the polar form. It's r times cosine of theta plus I times sine of theta. And then from here we have r equals to 3, right? And then cosine of theta, so cosine of 3 pi over 2. This time I'm writing with radians, and then I times sine of 3 pi over 2. Guys, this is the trig form or the polar form for a complex number z equals to negative 3i. So pretty basic, guys. For all of these 4 examples that I have done here, the key is to write or rewrite them with a real and imaginary part, then plot that complex number. Once you plot it, then you can see how to find the value for r and how to find that angle. Once you have the angle and the r, you bring it all together and you write the polar or the trig form. Okay guys, see you next time with another example. Till then, take care.